Okay, so if I talk about Python, so we have completed till lists, and in this class we'll be going through tuple, set, and dictionaries. So till list we have done. So list are nothing but mutable. So you can change the list. So list can be represented in square brackets, and you can insert, you can extend, you can you can append, you can do whatever modification you want. You can edit the list. Okay, but when coming to tuple, so if I talk about list, so list are ordered. Okay, so a list are ordered in the sense in what way you give the data, so that same way it will be represented. Okay, so when coming to tuples, so we have opened this tuple. So tuples are similar way to list, so they're immutable. Only this thing, okay? Because of this immutable capability, I mean, since does not have mutable capability, so there will be less functions. Will be there less functions because since are mutable, which where we can modify them. So that's why we got append, extend, this all things, right? So, but in case of tuple, so it's not the case. So tuples are similar to list, but they are immutable, cannot be changed. So tuples are enclosed by the parentheses. Did I go through this in the last session? I think I have gone through this. Okay, so maybe, however, I'll go through this. Okay, so my tuple, so which we are doing 1, 2, 3. This is Python is fun, so which is fine. So we will be enclosing with this in parentheses, not with brackets. So I mean square brackets. If you are enclosing these things with the square bracket, that is called list. Okay, this is tuple now. So I'm executing this. So these are also ordered. Ordered in
Vinay,
this is how you have. Yeah, yes,
Vinay,
Priyanka.
your screen is not visible to us. You didn't share with us.
Oh, okay, okay. Yeah, sorry. So yeah, this is my list. So I just opened a notebook which has tuples related operations. So tuples are similar to list, but they are immutable, and tuples are defined by enclosing the parentheses elements in the parentheses. So lists, right? So lists are within the brackets. When coming to tuple, they are immutable. I mean, you cannot edit the existing tuple. So if you could say my tuple is there, we have enclosed it in 1, 2, 3. Python is fun. We have enclosed it in a square bracket, normal parenthesis. So how you have given the elements, the same way you're able to see when it is printed, same order, right? So accessing the element, same way how you access the elements using index, the same thing as how you do for list. And then how you concatenate is same thing, like you do place how you do it for list. But you have to this is, you cannot modify the existing tuple. So tuple one dot append, so that kind of things you can't do, because whatever you have defined, that is final. Okay, in case if you are adding again tuple equals to 1, 2, 3, 4, 5, so that is different story. I mean, that is something different, you are assigning again, right? But you can't edit the existing tuple. So tuple one dot append of 4, that means it won't add 4 because it says it is immutable. So Python tuple 2, we have this, and we're just joining with place condition. So that is what concatenation is. And again, you might think that you said tuple is not immutable. Sorry, tuple is immutable. So why we can edit this? We can edit this because we are creating one more tuple using this tuple. Okay, we are not modifying the existing tuple 1 and tuple 2, right? So that is what immutable is. So you can see 1, 2, 3 Python is fun is in the single tuple, which is combined tuple. Okay, which is the name we have written as combined tuple. And tuple repetition, so if you want to repeat the things, so if you have this one element, if you have three elements, that will be repeated if you make it into three. So this can be also possible for another sequences as well. I mean, another iterators like list and all. But yeah, and slicing, you already know what is slicing, so I don't want to tell again, because list slicing we have done. So same thing, tuple as well. So two column 5 means it will give you a third position of the list, and the end at the fifth position of the yeah, tuple, sorry. So it should be tuple. So my tuple we have, so if you could see, 2 means 0, 1, 2, so it starts from 3, 4, 5, so it will be till here 3 Python is, that's it. And checking if an item exists, so you can check if an item exists in a tuple by using the in operator. So you already know what is this, like just Python in operator, right? So you are using this element is available in my tuple or not. So we are just trying to find it. That's it. In means checking whether that particular element is available in that or not. So you are using if condition. We are printing that if it is available. If I write not in, it should not be printed because it's not right, right? Python is there, so this should be false. That means this should not be printed. And then print length of my tuple, so which will print the length of the tuple. And then counting the elements, you have count of Python, so which will be counting the number of times this repeated. Okay, let's suppose your tuple is, if I try to add this, let's write Python here in a single quotes. Okay, so if you could see, this is there, but I added in combined list. So let me take this combined and show you how many. And then verify enter. So combined tuple count of Python is, okay. So P is capital and small, so that's why yeah, that's why it has an issue. So let me add this again, capital to small. Okay, now it should work. It should it should ask me 0 because my P is capital while searching. So now it should be 2. So it checks for the occurrences, how many times this element is available in the tuple. So yeah, and then index, finding an index of an item. So let's suppose we have my tuple, and then we have tuple. This is at last, and I'm just trying to get this index where it is. So you can use index of 1, which is 5, because 0, 1, 2, 3, 4, 5. So we have written 5. So that is what how to find the index. Unpacking the tuples in the sense you have fruits, and this is a tuple, and for each element I wanted to assign to a variable. So you can write whatever variables you wanted to assign to. So green, yellow, red, and equals to fruits, right? So green equals to apple, yellow equals to banana, red equals to cherry. So likewise, you will be able to assign, unpacking the tuples. That means assigning multiple elements to multiple variables at a time. So that it was uh, unpacking is. So joining, we already discussed this join. So I'm just skipping, just place concatenating, which is means joining the two tuples using just plus symbol. So I'm just saving this. Okay, so since tuples are immutable, you might be thinking how I can edit the tuple, right? So you have casting, right? So casting in the sense converting some data type to different data type. So what you can do, you can just convert this list to tuple, tuple to a list, and then do the changes whatever you want, and again, store it back to tuple. So this is what I have done here. So you can see this is tuple, this is tuple, and then if you could see tuple, and then I'm just converting this tuple to list of tuple 1. So you can see which is list, which is represented in square brackets, which means you can write simply list and open the brackets and close the bracket. Within that you can write tuple. So now what I'm doing, I'm just creating it and assigning it to some list. Yeah, 1 minute. So maybe I need to add him. Satya is pinging. Okay. So next we have a list and we are just appending and for. So if you could see, I am appending. So yeah, here if you could see, there is a list. So we have converted the list and assigned into some variable here. And now they're trying to append the element to the list. And again, we are trying to convert, now you can see 4 is added. So now I'm converting this list to tuple. So that is what I'm just running. Python will be added. So this is how it does. Okay, so this is a list, converting the tuple to list and making the changes so that, immutability capability we are able to, cover in the tuple. So that is what it is. So tuples are represented in, parentheses. You can give elements, and then there are few things we have learned, like, joining, indexing, counting, and how to convert the list to, tuple to list and list to tuple. So this we have done. Yeah, that's all for the tuple. So because since it is immutable, so, we also gone through accessing how it will be accessed. Since it is immutable, it doesn't have much functions. So you can go through that. Yeah, that's it. Sets we have. So sets is one of the data structures. So previously we have gone through list, tuple. Now we are going to, uh, sets. Sets are nothing but they are in, unordered, unindexed, and does not allow duplicate values. Okay, and they are represented in curly brackets. And now you can see I'm writing a variable called my set, and open the query, curly braces, and close the braces, and then you can write the things. Okay, and you can say why it is unordered. If I'm entering this, you can see, right, I'm entering this way 143 1423 Python is one fun. But if you could see 1 2 3 4, it is jumbled, right? It is shuffled. The data how you gave, it is shuffled. So that is what unordered. When coming to list and tuple, it's not like that. What however you do data you give, so it is not shuffled. So that is why lists are ordered, and these things. And when we talk about duplicate values, since these are unordered, how it can be indexed? No, right? So since it is unordered, so it cannot have proper index as well, indexing as well. So when I talk about unindexed, so however you can't access the element using, index, because if something comes up in the next one element comes up into the same list, again the indexing changes. So that shouldn't be happen. And do not allow duplicate values. So do not allow duplicate values means we have entered fun twice, but you can see the output is only once. So that is what duplicate values is. Okay, for adding an element, you can use add. Okay, like my set dot add of element name, like whatever you want to add, you can add it. So and I just printed it, so you can see Avsam is there in the list. So previously that was not there, so now it is there. So updating a set is, so updating a set, so basically adding another iterable. So iterable means any kind of list, tuple, anything. We can call it as iterable sequences, anything that's, you know um, it has different names, data structures, data types. You can call whatever you want, iterable sequences. Uh, so likewise, so these are list of elements in the list. Okay, so update means we are just trying to add these elements to the my list, my set. So you can see that elements got added. Okay, so now I'm removing the elements. So how I'll be removing the elements? So I'll be using remove keyword. So remove is a function where it will be removing the elements. So if I talk about these things, so we have fun, right? So I'll try to remove, yeah, we have is. I'll try to remove this is and again print it. So list dot remove, I mean, sorry, set dot remove, and open the brackets, close the brackets, and within that you have to write the element name. So I'm running. Okay, so now this is removed. Again, if I run this, what happens? It throws an error because is not available as of now because it got removed, right? So it is not available. So by the way, these sets are mutable. Okay, you can change. You can see I have removed it. That is what the mutable is. I can add, I can remove it. So these things we can do. So this is the disadvantage of remove. So if there is no element, it will throw an error. Okay, so if I talk about discard of 2 means it will remove the element. So if I just go and check the updated my set, I'm just trying to comment it. I don't want to run this. I want to run only this. I have two, right? I'm just trying to discard it too. I mean remove the two. So now I'm removing. Okay, it's removed. And again, we don't have in updated one, we don't have remove. Sorry, two, right? Again, I'll remove. Again, I'll try to run it. It's not throwing error. So that is a difference between remove and discard. So remove is something whenever you are writing some value over there in the remove function. So it will check whether the item, that particular value is available or not. Okay. So when I talk about set, so this particular value, it will set discard function. So it will just check if it is exist. Okay, remove it. Otherwise, just ignore it. That's it. So, but remove will throw an error. That's it. Okay. So this is the two differences. So any doubts still here? Okay. I hope you don't have any doubts. So yeah, if you have doubts, please feel free to speak. Okay. So this is discard and remove. So check if an item exists. You already know how to check this. So we have been going through different, list tuple and also everywhere syntax is same. So length, len function is used to check the size of the elements. I mean, how many elements are present in the list or tuple. So set operations. So union means this is one set and this is one set, and we wanted to add these elements. So you will be using union and underscore, pipe symbol, which means adds 1 2 3 4 5. So in particular, so 1 2 3 3 4 5, but it is trying to add this 3 4 5, but 3 is a duplicate number, right? So at the time it will remove 1 3 and add, I mean, keep 1 3. So that is what sets future is. If you are having duplicates, it will remove it. And intersection, so whatever common columns are there, so three will be written. Okay, so likewise. So difference, so sets, right? Sets, in sets we have, in our childhood, maybe in 10th class we'll be having sets. So same way, union, intersection, difference, symmetric difference will be there. So I'll share it with you so you can just go through this. So iterating through a set. So for loop, so for item in my set, print item. So that means it will be iterating through each, each element. I have 1 3 4 functions. So likewise, it will be going through different element. Yeah. So any questions still sets? Okay. So I think I hope everybody is fine. So yeah. So next we'll go through if else statement. So if else statement. So we have already gone through it. Okay. So during, I think we have gone through it. Yes. Come control flow statements. Yeah. Yes, we have gone through, but quickly, I'll quickly go through this. So now we have said age equals to 19. We are writing if age greater than 18, eligible to vote. Okay. Else not eligible. So now age is greater than 19. So which output it should be printing? Okay, age is not different because I didn't run age. So now it's saying eligible to vote. Okay. I'm writing age is 17. 16. Okay. Now if I write not eligible, so that is what it is doing. And if else, okay, if else elif. So you have this if, okay, we have implemented and in this. That means if both are true, then only true, right? So 18 greater than 18 and less than 50, then only this people, this particular, fall into that range till here. Okay. So next we have elif. If age is 7, register the portal for register in the portal for voting school. So if age is greater than 50, senior citizen, and else not eligible. So that is what it is. Okay, so we can build a logic here. So that's, yeah, that's what we have built, right? So and then inside this we are also again, if this case condition gets satisfied, again it goes to this condition. Okay, if greater than 18 and age less than 20, so we are writing his age is between 18 and 20, just to logger, just to understand the code I have written. So it's not a big deal why we are writing this, no need to care about it. Just to as a logger, that and moreover it has to be understandable to students. I'm writing this, print statements that this particular code is ran. Okay, and then again we have yeah, this all things are same. So I'm skipping this part because we already learned it. So you can go through recordings if you didn't go through break and continue all the statements. And then if else statement is done, and next we'll be going through exceptional handling. So exceptional handling. So exceptions are the one which will which are important in any of the Python code or Java code, because these exceptional are helpful in reduce the code errors. So basically, let's suppose that there might be an error upcoming. I mean, there might be a potential error, right? So that you have a script, and in that somewhere you try to read a CSV file from S3, but the CSV file is not there. Okay, sometimes it won't be available as per the client, sometimes it won't be available, let's suppose. So at that time you can just create, in order to not to disturb another scripts or disturb another process, so you can just use exception, so that you'll be able to handle those errors. So what happened, so exception handling, we will be having four kind of blocks. One is try block, one is except, one is else block, one is finally. So try block encloses a section of code where you anticipate potential exceptions. It is segmented where the Python interpreter will monitor for sure. So try box is something where it will check for some exceptional, like you will be having code. So let's suppose generally if we talk about one thing, can something is divided by zero? No, right? So that would be zero division error, right? So if something is divided by zero, yeah, that would be fine, but cannot divided by zero. So sorry, I have told reverse. So cannot divided by zero means if 50 divided by zero, which is wrong, right? If something is zero and you are intoing it, it will be correct. So basically we are planning to demonstrate this try exception handling using one of the simple programming language, I mean programming approach, like try except block else finally. So try we will put conditions where we will be anticipating some error in the condition. So if you could see try block num1 equals to int of input, enter a number, right? And you have some more thing like enter another number, right? So what you will be doing, you will be entering some number from the UI, like you will be writing 50 and again 30, something 50 and 30. So at that time, so it will give you the result, right? So if it gives the result, so this will be executed. Okay, and then once the result is executed, it will go to else block. Else block is executed if no exception is raised. Okay, but if you are trying to, instead of int, we are expecting int from the program, and if you are not providing integer value, instead of that you are providing some hii, which is a string value. So this will raise an exception, right? This try block will raise an exception. I mean, try block will tell to the Python kernel that there is some issue with the input variables, that we are expecting int, but they have provided string. So later, once this raises, this all blocks related to except, okay, except will be uh, you know uh, executed. So now we have done some kind of, let me check this way. So I'm entering a number here. So it's asking enter a number. So this one. Okay. I'm just entering hi. I'm entering. So you can see invalid input. Please put a valid number. Okay. This always be executed. So which one? This always be executed is this. So I'll talk about the definitions, but just try to understand the hands-on. Uh, so yeah, so this always be executed means this is printed, right? So now you understood that finally block will be executed whether you get an exception or not. It doesn't care whether you got an exception or not. It doesn't care. So when coming to except block, so if there is an exception in the try block, so definitely it will be printed in the except block. And then if I talk about else block, if no exception is raised, okay, then else block will be printed. Else block will be printed. So are you clear till try except and else? And finally, so just again one more time. So try block will check for exceptions, okay, potential exceptions based on our syntax that we provide. And except block, if there is an exception in the try block, so it will provide like this. I mean, this will be providing the print statement like cannot be divided by 0. If you're trying to divide some 50 divided by 0, which is not divisible, right? So it will throw an error, cannot divided by 0 error. And again, value error, if you are providing some invalid data types, let's suppose this asks for some like integer. So I provided a high, so which is an invalid data type. So that, okay. So else block is the one which will be executed if nothing, if no exception is raised. Okay. So that's why I'm printing result, and also I'm just show, like I'm just printing result, and also I'm just trying to look at the logger using I am from else block. Okay. So finally is the one which will be always executed. It doesn't care whether the exception is handled or not. So it will just execute it fine. However, okay. Any questions related to exception? Any questions? You can type in the chat. If you're hesitate to, unmute yourself, you can type in the chat. Akhil, Priyanka, am I speaking or are you listening, guys?
Yes, Vinay, we are listening.
Because no one is responding, so I'm just confused whether you people are with me or
Yeah, we are with you.
No doubts,
okay.
Vinay. You can continue.
Okay, then fine. So next we have gone through exception, right? So how this will be used in real-time data, I mean data engineering. Okay, so this is simple basic example that I have gone through, Python code, and uh, simple simple thing. It is simple, right? So I'll try to show you. Yeah, this example I didn't show you this one, right? Exception, this we just raised an exception of value error because I tried to give high, which is like it is expecting integer, but I gave string, so which is like value error. So this value error is nothing but it's a Python built-in error. Okay, it's not the custom one which we have created. So that also we can do, but it takes some time, so that you have to go through documentation and all how to create a custom, exceptions. So now value error is something which means whenever you give some different value for the input value which the Python is expecting, if you give the different one, it will throw an error. But division by zero, I'll try to divide something by zero. I'm entering one number which is 70, and I'm entering zero. So let's see whether we get an error. Okay, you can see error cannot divided by zero. So this is smooth way of getting out of some errors. Okay. So if you're not handling this, you're not writing this. So let's suppose if I'm simply writing 70 divided by 0, let's see, it is throwing some error like this, right? If I execute this try block and all this kind of approach, it is smoothly not executing any red flags, right? So this is not red flag. So if I write 70 divided by 0, so it is simply executing something. So, but here if you could see red flag. So this is what error. So this kind of errors we are trying to, you know, uh, anticipate. I mean, if you're anticipating some error like this, you're trying to use try and except block so that the rest of the script. So let's suppose, so if I have print rest of the script, okay, print high, okay. So I'm just writing EIT divided by 0. I'm throwing error, but still this high is printed, right? So what if I do, if I write this way, and if I write print high, will this print? No, right? Because this is itself, this line itself, it is getting, it's throwing error. So how it goes to the next line, right? So what we are doing here, we are just trying to create try except and this block so that it can handle the error smoothly. Okay. So that is what the benefit of exception handling in the name itself sees. You can see exceptional handling, like handling the errors or some kind of exceptions. So that is what it is. So in data engineering related framework, how you'll be doing this? So real time example. So let's suppose you have this existence of file function. So just don't bother about this function. We didn't go through till here. Like we didn't try to create a function like this. Just try to understand that's simple, no, logic wise. So try open the file path. So that is nothing but 14.numpy.ipynb. So if you could see, that would be there here. So 14.ipnumpy numpy Jupyter notebook. So what we are doing, we are trying to open the file. If it is there, it's okay. It will print this. The file is exist because that goes to else statement. Okay. And then if it is except, so file not found error. Let's suppose if I don't have this file, it should throw that error, but smoothly it has to throw. It shouldn't throw like red color flags, which will which will what it will do, which will not run the next process, right? So that's why we implement try except else. If you could see the print, with the help of print, I tried to help show you how this is print high is printed, and how sorry, how this print high is printed, and how this print highs will not be printed because of this error. So here if you implement try catch block and try except block, so it would be easy actually. Okay. So check file existence, so file path. So we are just trying to open the file, and if this is not found, we are just saying this, and if it is found, we are just printing it in the else block. So I'm just running this. So it is exist. Okay, the file exists. And if I write this something like this, it should say, it should throw an exception, but smoothly. So you can see smoothly it says the file doesn't exist. That's it. So that is what real-time use case of a exception handling. I mean, maybe in you'll be having a lot of things, but this is one of the real-time use case. Okay, so I'm just if you have any doubts, we can discuss related to exception handling real-time use case. But if you don't have, so we will be progressing to the next one. So yeah, let me know. I'm just yeah being passed for 10 seconds, 20 seconds. You can think of exception handling. Okay, so now then I hope you don't have any doubts. So and then since we done exception handling, we'll go through functions. Okay, so functions are nothing but say it is nothing but you are enclosing something in one particular some body of the code in particular block. So generally I'm writing this I'm just simply opening a notepad, I mean notepad file, and saving it as .py extension. I'm writing the code like simple code, print high, and I'm writing few other things. Okay. So likewise, I'm just doing the many things like print or doing some operations, reading the Spark tables using PySpark, something like that. So if I execute this code, this .py extension code, if I save this as a something like vinay.python, I'll save this as a vinay.py file. Okay. So if I execute this, everything will be executed in sequentially, right? This sequentially. Everything will be executed in sequentially. So because without we didn't write any function at all. We didn't write any function at all. So what we are doing, so here we are just trying to create a function using def keyword, def, and vi, and open and close the brackets. So what I'm saying, hello from a function Vinay. Okay. So let me run this. So did it print hello? No, it didn't print anything. It just ran it. If you could see whether it is ran or not, you can check this one. So which means ran. If something is there, it will be star. Okay. You can see I changed something. You can see star. That means it didn't run. Okay. So this is what it is. And now I ran this, but nothing output. Just check for some syntax error. But let's see what is function calling. So if you could see, this is calling the function. This is calling the function. So you can see hello from Vinay. If I write something hello from Vinay and Akin, So again, I need to execute this. And again, if I execute this, you can see the updated code. So one thing we have learned is defining the function. You can name whatever you want. I just named it VI. You can name whatever you want. That depends on your business requirement and your personal interest. I'm a personal project. So VI and open the brackets and close the brackets. Print hello from this is the body. And since we have one single line, but in future you'll be having a lot of code in the function. So here it's a simple program, but in future in your projects you'll be having lengthy of code in the function because functions are defined to you reuse the code actually. So reuse the code in the sense. So this function I have used it here. Again, I can run, call this function in the next line as well. So you're not writing the code and again and again. You're just calling the function. Okay. So you're just calling the function. So now the other way of writing a function is lambda function. So lambda function is nothing but its name is anonymous function. So anonymous function means stranger, right? So basically anonymous person means stranger. So in the same way, we call lambda function as anonymous function. Anonymous means we don't give any name at all. So if you could see vi, we have given some name to the function, but if you could see here, we didn't give any name at all. So simply we have written k equals to lambda x comma y and x plus y, right? So k means what? It is just a variable. So and again we are implementing 10 comma 15, which means it is accepting 10 as x and y as 15, and then it is adding this x plus y, okay, and then which is for 25. So that is what function is, and there are other things. Yeah, any questions still here related to function? Okay, so I hope you don't have any questions related to functions. We will be progressing to next things like x equals to avsum. Okay, we have written this. So whatever you're writing outside the function, okay, outside the function, that is called global variable. Okay, global variable means if I run this function now, just forget about the answers like Python is fun and this thing because I called this function. That's why I'm able to return this. Let's suppose I just ran this. So now I'm executing this x value x. It should be printed because this is global value because that is outside the function. So let's suppose something is inside the function and I wanted to access m. Okay, I wanted to access m. Will it work? No, because that is within the function. It's a private variable for us. I mean, globally you can't access, right? So you can say m is not defined. So it is defined, but it is in the function, but it's not accessible outside the function. So that is what local variables are. Those are local variables. So this is global variable and this is local variable L and M. But in order to make this local variable to global variable, you can define like this global L. So which means Vinay will be also, sorry, L will be also global variable. So now what I'll do, I'll just try to do L. Yeah, you can say L is there. So you can say Vinay is printed. So if I remove this one, let's see, will L is printed? Okay, so it is getting printed, but I think that is stored in, uh, already it was global, so I won't want to make it, and I'll just try to make it K. Now I'll try to check K because already L became global. Oh, K is already print lambda function. So let's make it n. Okay, n won't be there for sure. So n I'm printing it. N is not defined, right? So what I'll do, I'll just make this n global. Global n and then exit this. So now your n will be printed. Oh, it should be printed. Okay, let me go back to the previous. Okay, I'll stop this kernel. Something is happened. Ideally, it should work. Start the kernel. Okay, so now I'll just try to make it in, and I'll just try to remove this first. Now n is not defined, but I'll try to make this global variable. Okay, I'll change the function because already we are running this function. Maybe that might that is taking some n. Let me check n is defined or not. Okay, I'll check this later on. I think I'll just check it now itself. Okay, seems like whenever we are doing at the same time, you have to do. Okay, I'll just go through this later on. So there is some issue, but ideally it's okay. Got it. Okay, no, it's not an issue. I think I need to call this at least once, I guess, in order to make this local to global. So that's what missing actually. Okay, so now this is fine. And if I run this, it should be global because I forgot, I just removed this code. So if you don't call this, how this code will work? It will not work, right? Once it will be called, it should be called. So I thought I had this code, but it is, it's removed actually by me itself. It is removed. So at least once you should run this because that will convert local, that will execute this code, right? So that's why. So generally, whenever you are writing a function, if you define a function, and if you leave it like that, it will just check for the syntax, and whenever you call the function, then only that execution will happen. So just try to remember these things. And next thing, so how to give a parameters to a function. So this is def add. We just didn't know what is this, but right now you can, these are parameters. Okay, previously we didn't give this for vi function. So right now, if you could see a comma b, which are parameters. So we are planning to do a calculator kind of, a plus b environment for a Spark, sorry, for Python code. So add a comma b, print a plus b. Hi, this is add function. I'm printing like that. So I just ran the function which is defined in the memory of kernel. So now if you could see add 5 comma 10, which should be printed 15, right? And also this. So this is how you give the parameters. In real life, you'll be giving a lot of parameters, maybe 10 parameters. So that depends on the, reusability of the code. So you can give parameters. Sometimes you have to hard code it, but generally people try to make the code generic using functions. Generic means this function should be used in different places. So you will not try to rewrite the function again and again. So you will just try to use the same file again and again wherever necessary. Okay, so this is all about functions. So there's nothing much here. So whatever we have discussed again and again, it's represented. So I'll send you this notebook so you can just keep on practicing, and you can just go through this. So one thing we have learned here in functions, one is lambda function, which is an anonymous function. So and then the other one is a normal function, which is which without any variable, without any argument, simple vi. And then we have executed how to define that, how to call that, and later on we have gone through how to give the parameters like arguments to it. So that also we have gone through. Okay, so till here it's fine, 10. And then we have one more thing, like if you want a break and if you wanted to do the things, so we can leave. I mean, we can wrap up the session, or else if you're fine, we can just go through the few other things as well. So how would you suggest, you guys? So are you, I mean, you'll be waiting. I mean, are you okay to have few other topics, or will you be practicing for a day and maybe tomorrow you'll be having the class?
We need time for practicing, Vinay.
Okay, so till here you can practice today, and tomorrow at the same time we can have a class.
And I think one class is not uploaded in the drive.
Uh, we had two sessions, right, for Python and Python.
No. Yesterday, did you take the class, Vinay?
No, we didn't take. Actually, people didn't respond, so I didn't get a chance to take it.
Okay, okay.
So if you could see, so the last class was on Monday. So Tuesday we were not in a, Tuesday is yesterday, so we didn't take it. So
Saturday, Sunday,
Monday,
Monday.
so Monday also we didn't take it, I guess. So this is the last recording that we have where we discussed the list. So the same recording is in this. So yeah, that's it. So this is the same recording that we have. Yeah, same recording.
Okay.
So this class will be there, and I'll be writing its name as till functions. And if you go to this hands-on exercise, so if you go back to this folder, so we have hands-on codes, and then in that you have Python tutorials. You can check all these notebooks. Okay, so yeah, okay, Priyanka. So then we can wrap up the session, and you people can practice for half an hour, 1 hour. That would be fine, I guess. Soon after you are, if you practice after the class, so that would be great. I mean, you'll be able to get all the most of the things. But if you delay, so it might take time. So just take this, pick this notes, whatever it's when in the Python. So whatever we have learned, so just go through those things. So yeah, that's it. Even if you're not looking at the recording again, so you can just go through 1 2 3 like this straightly, I mean sequentially, so you'll be able to understand the things.
Okay, Vinay.
Yeah, okay, Priyanka. Thanks, Akhil, and thanks,
Yeah.
Satya.
Bye, Vinay.
Bye.